Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
I got a new audio setup at home.
Ooh.
Very happy about it.
Yeah. It's always fun to get a little time to work on the gear.
Yeah, there's so many inputs to outputs and outputs to inputs, and I actually had to string 3 audio interfaces together to get this to work.
Nice.
I know. Everybody's like, why don't you just record your Skype call? No, this is .NET Rocks.
No. Yeah, we're famous for making audio that sounds really, really great. It's a little more complicated to record it when you do it that way.
Yeah. What about you? You got anything to announce?
I've had, I don't know why the summer is such a crazy time for recording shows, but over on the Run As side, I've just had a string of interesting shows for August.
Good.
So first show in August was with Paul Thurrott, and we talked about how the Windows team has been broken up and moved into different areas, and Terry Myerson moving on. And of course, Terry and Paul have known each other very well for years. So it was just a cool conversation. And of course, got a lot of excitement and conversation around that. And then I followed it with a show with Susan Bradley, who's one of the patch mavens. She's the person you turn to when you're having trouble with patching operating systems and things like that. And Windows Update has not had a good past few months. There's been some nasty patches released by Microsoft that even broke like Microsoft products. Like there was a security patch for the .NET framework that broke Exchange. Not good.
Not good.
And so she put out an open letter saying, look, we have to do better. Here's some ideas, things we could do. And I did an interview with her to talk about it. And it got picked up by some press. Redmond Mag ran an article about it. So that's been exciting. And this week's show, just because it's fun, underwater data centers.
Nice. Hey, I remember talking about that.
Yeah, you remember when that first came around, the Project Natick?
Yep.
Well, I managed to get Ben Cutler, who's one of the principal scientists behind it, to come and chat with me for a half hour.
How
cool. And we really dove into the nitty gritty of what an underwater data center is all about. And he was kind of relieved to finally be talking to someone who's built a data center or two.
Yeah.
And he's going to ask about leaks and fixing the computers. Is like, hey, Sparky, nobody fixes the computers anymore.
We just shut them down. Turn another one on.
But his whole point, not that I want to give away the ending, was they figure they can light up one of those cylinders in less than 90 days. And you cannot build cloud scale data centers that quickly on land.
Yeah.
So the fact that they can mass manufacture these things and put them down in harbors and other watery areas and save some energy and be efficient, it's just a really interesting story if you're into that sort of thing.
So if you're down for 90 days, how many nines of reliability is that?
yeah, that would not be good.
Not be good. I know. They're never down for 90 days.
No.
Anyway,
Anyway, cool. Just one of those crazy summers over on Run As.
Nice. Well, the other thing is I got me a Traeger grill smoker.
Oh, you did it, huh?
I got the wood pellet smoker. I did some ribs. They came out great. We'll talk more about that.
The little corkscrew driver.
Oh, yeah, it's great. It's nice.
I love it. That's awesome.
Nice grill. All right, let's roll the crazy music for Better Know a Framework.
Awesome. All right, dude, what do you got?
It's a summer's evening. I'm sitting here at the house. I got a nice little cocktail here. Nothing pleases me more than to blow up somebody's Twitter feed by announcing it on .NET Rocks. That's just something I enjoy doing, Richard.
Right.
So this is a very cool, the account is @within, and it's within VRAR, and they're highlighting artists Adrian M. and Claire B., who have an art exhibit called Mirages and Miracles. That's an augmented reality interactive art exhibit.
That's cool.
Now, you don't have to use glasses or goggles or anything. You hold your phone or your iPad or your tablet or whatever it is up to the art, and it just comes to life.
When, of course, the video that I'm looking at here is from the camera. So it's just,
That's right.
From the phone. So, of course, it's just there are things happening in this art.
Oh, yeah. And, you can interact with it with your hands and, shape things. A lot of particles floating around in silhouettes dancing in 3D. And just, you can't describe the art. You have to just go and check it out.
It's really extraordinary. What a cool find.
It is a cool find. Yeah. I sat there and watched it over and over again for a few times. So
neat.
That's what I got, Richard. Who's talking to us?
Grabbed a comment off of show 1316, which we did way back in June of 2016 with one Jennifer Marsman. talking about lie detection using Azure machine learning.
Yeah.
It's kind of amazing to think that was only 2 years ago and how far we've come with this tech. And it's just so much more mature. But this is a 2-year-old comment that I think is still super relevant. Because in that show, I don't know if you would recall, I know we've recorded a few shows since then, like 300. You talked about using machine learning around medical information, being able to identify disease better and so forth. And Brent Vandermeed at the time, 2 years ago, says, so check it out, mediswarm.com. It's been in the works for about a year, and this was 2 years ago, and is aimed exactly at what Carl was talking about.
Wow.
And I pulled up MediSwarm, and it's exactly that. It's, thinking swarm information for understanding illnesses and allowing people who share an illness to connect with each other. So that social media side.
We do that now, but so inefficiently. We search through forums and things and try to find people who've had similar experiences. And, and oftentimes it's too simple. It's too simplified, and there isn't a rich set of data there that you can actually learn anything from. There's just anecdotes. So I love the fact that people are doing this, and I wish people would not be so afraid about sharing their medical information so long as it's anonymized, and to allow science to progress at an amazing clip. I mean, we could do so much with this if we had that kind of data.
Absolutely agree. And Brent went on to say, I'm a longtime fan of .NET Rocks and a one-time guest on DNR TV. There's a blast from the past.
Right. Yep.
And it's pretty cool to hear you guys calling out for such demand on your show. Love the episode and all the energy behind it, because I think we had really a lot of fun with Jennifer. She's not that restrained a personality. So Brent, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. We turn him into clouds of little particles. Hang them on the wall. Cloudy particles.
Let them float around.
All right. Let's introduce Jennifer. Jennifer Marsman is the principal software engineer of Microsoft's AI for Earth group, where she uses data science, machine learning, and artificial intelligence to aid with clean water, agriculture, biodiversity, and climate change. Jennifer is a frequent speaker at software dev conferences around the world. Since 2016, she was recognized as one of the top 100 most influential individuals in artificial intelligence and machine learning by Analytica, reaching the number 2 slot in 2018. She's been featured in Bloomberg for her work using EEG and machine learning to perform lie detection, as Richard was mentioning. And there's so much more to her bio, you'll just have to read it all at .netrocks.com. Welcome back, Jennifer.
So happy to be back, you guys.
So happy to have you here.
We usually get to do this in person, which is really fun. I think the last time we did a show together is when we also had Evelina and Barbara, and we did that panel discussion.
Yep. Oh, I loved that panel discussion. And one of the things that was so awesome about that panel discussion is that it was an all-women panel that was not discussing women in tech.
Yeah, right.
No.
And that was so awesome. Yeah.
I get to build panels based on the content available, and I found 3 distinctly different AI experts and said we should put them on a panel. And it turned out they're all women. Mm-hmm. But they're also had been on the show before and friends of ours. And it was just, it was a really cool conversation. But
it was a geek out extraordinaire.
Totally.
Yeah, that was
Evelina
fun.
came at from the data science R perspective. You've got all your machine learning work around the EEG, Barbara and the analytics side. So it was just really cool.
That was fun. That was a lot of fun. I agree.
So what are you up to lately?
Well, I've recently joined a new team at Microsoft, which is AI for Earth. And it was one of those things where, I wasn't unhappy in my old job, but I heard about this program and I got hooked. Because the idea is, how can we use all of the advances that you were discussing in machine learning and artificial intelligence to aid with big environmental challenges on Earth. Yeah. And we do have those 4 focus areas that you mentioned earlier: agriculture, water, climate change, and biodiversity. And last December, Microsoft publicly announced that we were going to give away $50 million in grant money over the next 5 years towards anyone doing machine learning or data science in that area. So whether that be a startup, an NGO, there's various nonprofits, a lot of academic institutions, or just large corporations as well. Anyone who is doing data science in those focus areas are eligible. And so I got really excited when I heard about this team.
Yeah.
And a lot of people focus on the number, on $50 million. But one of the things that got me so excited was actually the time. Like, it's $50 million over 5 years. And for Microsoft to make a 5-year commitment to something, like in computer terminology, in the world of technology, like 5 years is an eternity.
Oh, yeah.
So I was really excited about, wow, this is a real investment when you put that kind of timeline around it. And so, I love doing the lie detection work, and I had, been doing a lot of other work that was cool. But, as you guys know, I have young children and such, and I do have to travel a lot with my job. And being able to actually use my passion for machine learning to do something to give back so substantially was just so exciting to me that I was like, I got to check out this team. And so I wrote a long essay about why they should hire me. And luckily I managed to convince the right people.
As Richard says, you've harnessed your OCD for the powers of good.
That's right. But it really is so cool, because when you think about it, like machine learning, it's come so far in the last 10 to 15 years. Like, I got my degree in artificial intelligence 15 years ago. And I like to say it's hilarious because they actually had a degree in AI then. And I think at this point, AI is too big. Now probably the degrees are broken down into like NLP or computer vision or kind of one of the subsets. But at this point, so much has happened in the last 15 years, like things like facial detection and automatic machine translation. And a lot of these things were just AI, this concept of something that could maybe happen in the future, and they're like solved problems now. And so being able to take all these advances we've made in machine learning and apply them in the field of, to big challenges in water, and how do we take and get fresh water, where it needs to be, flooding. When you think about all of the floods and all of the crazy stuff that's happened in the US and throughout the world with hurricanes and such, being able to predict, okay, as water levels rise, who should we evacuate first? Like, who do we need to evacuate and who is safe to stay? We need ML to do all those things. And then in agriculture, some of the work I've done, I've talked to you about the Farm Beats project before, but the idea of, I guess it was noted by the United Nations in 2009 that by the year 2050, we actually need to double our current rate of food production, or we're not going to be able to feed the world's growing population. Like the rate that our population is increasing is growing too steeply.
Yeah, it's not because the population is growing that much. It's because people are expecting to eat more. That, as we raise more people out of poverty worldwide, just the food demands are going to fundamentally change. Like,
I think if you teach people how to grow good pizza, then that's a step in
keto friendly as well.
Of course. I mean,
of course.
I've seen pizza farms out in the Midwest. That's kind of a thing.
It is. And the other aspect of that too is that you really have to grow things in a sustainable way too, because there's ways you can increase the yield, but you can really damage the soil in that you drain all the nutrients and then it's no good for a while. So you have to balance kind of the long-term and the short-term gains to keep that working at a good rate. And then all kinds of similar challenges in climate and in biodiversity, keeping a variety of different species alive. And we've done a lot of work in that aspect. But it's really exciting because we've already given 137 grants with impact in 45 different countries. So that's really, really cool to see that so many people are taking advantage of it. And if other people are doing work in this area, feel free to apply for a grant. It's aka.ms/AI for Earth. And then we also have a sister program called AI for Accessibility. And that one is $25 million. dollars. But that's stuff like, do you guys remember back at Build a few years ago, the Seeing AI application that Saqib Sheikh did, where he had the glasses on, and he was able to you swipe the side of the glasses, and it was using the cognitive services.
Oh, yeah.
Essentially read out loud for him things. And so it showed a whole bunch of different scenarios around being able to read a menu in front of him using
big picture as he's blind.
Yeah.
And the glasses see what's going on in object detection. He just touches his glasses and it describes the scene.
Right. It was the mood when he got the moods. It's like there is a woman who is smiling and a man who is frowning. Like, it was those little details that just made your skin tingle, right? It's like, wow,
it really
this
did.
is what I can see.
Yeah, so it is incredible for people of all abilities to be able to get the same access to technology. And so AI for accessibility is really focused on those issues. And the Seeing AI project has actually moved forward a ton since that video was released at Build. That one really focused on the glasses, but they actually have an app now, an iPhone app that you can download Seeing AI that allows you to do a whole bunch of different things. So you mentioned the aspect of being able to look at someone and be able to tell their mood. Well, you can actually program in, the names of your family and your coworkers, so that instead of just saying, oh, it's a 27-year-old woman, it'll say, oh, this is, Jennifer Marsman.
Right.
Or, those kind of things, and give people a better look. And it also does some really good stuff with currency. So recognizing money, that this is a $10 bill versus a $20 bill. I know in the US, they're all the same size. So that's harder for people with sight impairments to be able to differentiate between the different things when they don't have, in other countries, they have different size money for different denominations. And that's a little easier.
Well, in Canadian money, we also have Braille embedded in the money.
Yep.
So
yep.
Sight impairments can just feel it and go, oh, I know what this is.
That'd be a heck of an app right there.
That is awesome.
That'd be a heck of an app. What I'd like to do if I was going to hack an app like that is that every person would be J-Lo. It's like, oh, it's Shakira. You're, or it's like some celebrity. Yeah.
There you go.
The world's a beautiful, beautiful place.
That's right.
Oh,
yeah.
Man.
You mentioned getting your degree 15 years ago, not to change gears too much, but having done a bunch of talks and stuff around the AI space and mostly working on history things, was back propagation even part of your syllabus at that time?
It was, so there was, we did learn like neural networks and such were a thing at that point. And so, yes, we did, kind of, have the beginnings of all of that. We didn't have deep networks, to the level that we have today. So that's the main difference, was just kind of the depth of what was possible.
And was that mostly just a constraint of compute? You just didn't have the horsepower to do so many tiers and neurons?
Yes. Yep. Because when I first started at Microsoft, my first job was actually I was hired into the natural language processing group, which we called NLG, the natural language group.
Yeah.
And like one of the things that we were trying to do very early on, my team reorged like right after I joined, and I joined a group that was called the NUI platform, or the Natural User Interface platform, which was essentially trying to build Cortana or Siri or Alexa or any of these guys years ago. And so what we ended up doing was we didn't have a cloud, and that was the main reason that we didn't really succeed yet, was we didn't have the computational power that would enable us to move forward and make the progress that we needed to do. But we made progress in other areas. But
Now, and it's interesting how the voice technology shifted in that 2011 to 2013, when the compute sort of caught up and everything improved. But before we go further into that, Jennifer, let's stop just for this very important message.
Save the date for .NET Conf 2018, September 12th through 14th. .NET Conf is a free 3-day virtual developer event co-organized by the .NET community and Microsoft. Over the course of 3 days, you can enjoy a wide selection of live sessions that feature speakers from the community and .NET product teams. These are the experts in their field, and .NET Conf is a chance to learn, ask questions live, and get inspired for your next software project. You will learn to build for web, mobile, cloud, desktop games, services, libraries, and more for a variety of platforms and devices, all with .NET. There are sessions for everyone, no matter if you are starting out or a seasoned engineer. Expect presentations on .NET Core and ASP.NET Core, C#, F#, Azure, Visual Studio, Xamarin, and much more. Head to www.dotnetconf.net. That's .netconf.net to learn more and tune in.
And we're back. It's Richard Campbell, Carl Franklin talking to our friend Jennifer Marsman about AI for Earth.
Yeah.
Yes.
And,
yes.
What are you working on a particular project? Can we dive into it, or can I ask you about any of them? Because I'm looking at these things and I'm so excited.
Oh my gosh. So I could just talk for like an hour on all of the different projects, more than an hour. I could talk for the whole, I could do a whole conference.
Well, you got 40 minutes. Go.
Let's go.
40 minutes. Here we go. Okay. So
go.
in my mind, I kind of split the engineering work that we do into like 3 different buckets. There's a Microsoft research bucket and some cool projects where we partner with Microsoft Research on some of the cool stuff that they're doing and support that work. So that's one bucket. And in that bucket, we support things like Project Premonition and FarmBeats. And I would love to talk more about those because they're still really, really cool. And then the second bucket is kind of the first party APIs that we're building ourselves. And so what I mean by that is the end vision here is, so I think of it almost like cognitive services for the earth. So thinking of like, could we put together this collection of APIs that people could leverage to be able to help solve these big problems in agriculture, water, climate change, and biodiversity. So things like a general purpose species recognition algorithm or land cover mapping, which is it's a little bit niche. It's used by urban planners and a lot of other folks doing environmental work for precision conservation and things like that. But essentially the input to something like that would be aerial imagery. And then the output would be, pixel by pixel level, tell me, all right, this is water, this is a tree, this is barren. It's either a building or a road or something I can't build on. And so being able to do that, we created some APIs to do that with 1 meter resolution, meaning that 1 pixel represents 1 meter. And so it's a very high resolution. The ones that are out there right now are much lower resolution, where there's like 1 pixel is like 30 meters or something. So anyway, so that's another thing we're working on right now is land cover mapping and some of these other general purpose APIs. And then we're also partnering with our grantees and helping them be successful and potentially exposing some of the great work that they're working on as APIs as well. So there's a bunch of projects there that I'd love to talk about. iNaturalist is doing some really cool things. There's something called Spot and Pause. They're doing a lot of working around poaching. There's Wildbook. I mean, there's a whole bunch of cool stuff. So do you want to back up and start from Microsoft Research and I can dive into some of these different projects? I'd love to.
Yeah, can we start with Premonition? Because I just think the whole idea is so clever.
My gosh. So Premonition is absolutely fabulous. So the idea when Project Premonition launched, the idea behind it was to be able to predict the outbreak of disease before it happens. Wow. So there's, all these, remember the Zika outbreak that happened recently? All these things, like, could we have predicted that? Like, what can we do to use machine learning to do a better job with that? And so in order to solve that problem, we're actually using little data collectors that go around and collect biological data, and those are mosquitoes. You can actually mosquitoes actually fly around and they extract blood samples, right? And they do this from various animals. And so what we
knew they were good for something.
I know. I actually did not know they were good for anything because, you kind of look through, okay, bees at least, perform pollination and there's other things. So even if they sting you, I can very clearly see the good they're doing for the world. But mosquitoes, no. But yes, this is a great application for mosquitoes here. So here's, but let me just tell you how this works because this is so freaking cool. So basically we have a trap that can collect the mosquitoes, and there's actually machine learning embedded on device in the trap as well. So the trap is the current version of the trap is the cylinder that has 64 different little cells, so little doors that can open and close. And then there is a machine learning classifier embedded into the trap. So you can stick a lure in the middle, and there's various lures. Some of them are based on scent. Some of them are CO2. Some of them are light, but various things.
Some of them smell like Carl's leg.
A lovely aroma, I'm sure. So basically, these things all attract insects, and they can fly in and kind of check it out and then fly away. But we have a classifier. It's actually using light, and then essentially the wing beat speed of the insect is one of the main features that does this. So basically, the wing beat speed, it kind of acts as like a single pixel, light not light can tell the wing speed frequency or the wing beat frequency, and so then we can actually tell that something is a mosquito or is not a mosquito. So it's a little mosquito, not a mosquito classifier. So that way it'll shut that trap door only if a mosquito flies in. So then other insects, a fly or whatever else, can fly in, kind of check out the lure and then like fly away. But only mosquitoes are trapped in there. And so then, it doesn't actually kill them. It just traps them in there. And then someone can go and collect that trap and bring it back to a lab. And there we can take blooded mosquitoes and be able to extract the blood from them and then reverse engineer that blood using our genomics pipeline to be able to tell what animal it came from and then what diseases that animal carries.
Oh my God.
So yes, isn't that incredible?
That is great.
That's even possible. So you definitely need cloud scale computing because the human genome is just enormous. But basically it's we have kind of all these different animals, and then it can figure out what animal it is, and then figure out, things like a cow, like does it have mad cow disease, things like that.
Right.
So there's all these different diseases, and so it can figure out from there what's possible. And so we actually did some trials in Houston around the time of the Zika outbreak. And so that was very interesting to kind of get that data and then have a collection of human data and various animals. And then there's just some really cool work you can do to be able to do work. We're also focused on an area that's looking at a lot of, simian autoimmune, so it's basically the equivalent of HIV for simians.
Wow.
SIV.
Right, which the argument's always been that HIV came from the simian mutation.
Right.
Yeah, I think that's a myth, though, isn't it?
It may or may not be, but I think it would be very interesting to be able to, if there's a population with a lot of chimpanzees and stuff like that, to be able to gather information on how that's spreading there. And then maybe that might be applicable to some of the work with HIV. So there's just a lot of just interesting stuff you can potentially do there.
It's just interesting to think of the idea of using mosquitoes as your survey tool for biodiversity. How many different creatures' blood samples can you collect from a given area?
It seems to me I read a story where they were mutating mosquitoes to essentially not be able to breed.
Yeah, they were sterilizing them in Australia.
That's right. And then releasing them out into the wild, and they could wipe out an entire population of illness-bearing mosquitoes, pathogen-bearing mosquitoes.
Yeah.
Wow.
It's a method for getting rid of bad classes of mosquito, but even every mosquito bites for blood. The idea that you could, I'm thinking biodiversity, like you put this out in the wilderness, find out the spread of different creatures living in a particular radius.
Right.
That's absolutely a natural next step. Is the biodiversity angle. So that's something that we are looking at very, very closely. Yeah.
Doing it in an urban area to detect epidemic outbreaks. Like you should even be able to pick up flu viruses in those blood samples if they're bitten from humans.
Right. No, and that's always an important thing, is what strains of flu are happening right now and that sort of thing. So yeah, and the thing is, it really is cool how much faster they can happen, because it really is a very long process. So right now, when there's a disease outbreak, what actually happens is people get sick, they go to their doctor, and then the doctor kind of reports instances of diseases to something like the Center for Disease Control or World Health Organization, or one of these organizations that aggregates that data. And then they see that, we're getting a big, a whole bunch of reports from this one particular area. We have an outbreak in these areas. But that, by the time that happens, it's usually a month after the outbreak has already happened, right? There's all those steps of getting sick, going to the doctor, then the doctor kind of, has to report it to the next step. And then the next step has to aggregate that, or the organization has to aggregate all that and see that, we have an outbreak here. So the idea is, can we get out in front of that a little bit faster, and potentially stop some of these things before they become outbreaks? So it's an exciting thing. And then the biodiversity is something that's also very near and dear to us on the AI for Earth team. So that's something else we're looking at.
Well, Richard, guess what time it is now?
It must be that happy time again.
He sounds so excited.
I am happy.
It's time to announce an app that uses the accelerometer to notify you when an earthquake is happening. I call it Duh. I'd be lucky if I could hold on to my phone if an earthquake is happening. I don't need an app. Anyway.
You sure?
Maybe I do. I don't know.
Are things falling down? Are you falling down? You might be in an earthquake.
I just imagine, look, this would be a scene from a movie, the walls are falling in around you and your phone is going, you are experiencing an earthquake.
Yes.
Thank you. It's actually time to give away a free conference pass to Tech Bash, October 2 through 5, and up to 4 nights at the Kalahari Resort in Pocono Manor, Pennsylvania for the event. Compliments of Progress Telerik. If you want to check out more about that event, go to techbash.dotnetrocks.com. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.net and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing, and productivity tools, and comes with a range of support options. New this year is a free online training program for all license holders. With this, alongside thousands of demos with source code, comprehensive documentation, and a full assortment of Visual Studio templates, you'll be up and running with the Progress Telerik and Kendo UI tools in no time. Download a free 30-day trial today at telerik.com/download.
All right, buddy. Who's our winner?
Today's winner is John Meyer.
Oh, congratulations, John. Golf clap for you.
Congratulations, John. John just won a free conference pass to Tech Bash in Pocono Manor, Pennsylvania, October 2 through 5th, just for being a member of the .NET Rocks fan club. And if you'd like to be a member, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the fan club. But you got to sign up to win. We also like to ask our guest, Jennifer, if you had $5,000 to spend on technology today, what would you buy?
Oh my goodness. Honestly, I would buy, there's so many interesting toys that are used by these, the work that the AI for Earth grantees are using.
Right.
I would probably want one of those. So I would love a Project Premonition mosquito trap in my backyard.
Yeah.
Mainly just to get rid of the mosquitoes. But there's also a lot of things around just sensors and drones, like the amount of work that's being done with aerial imagery from drones right now, and how useful it is incredible. And I've used a couple different varieties of drones, the Parrot and the DJI and a couple different ones from different brands, and they're great. And then there's also underwater drones I've seen that I'd love to use those for some of these neat water challenges.
Yeah, right.
Yeah, I've got a waterfront place in my life these days, and I've got the flying drone, but I'm thinking about the underwater one too.
Yup. No, that's been on my wish list too.
The Otter Swim Cam, Richard?
Something like that. I mean, if the otters find it, they will take it. I will never see it again. But otters are remarkably mischievous. Like it is, but destructive. Like boy, oh boy, they make a mess. They live
let me know if you get
front.
one when you end up getting.
I'll send you some video clips. We had an army, like a dozen of them, come through the pond. It's quite disturbing, actually. It looked like a military movement.
That's awesome. That's awesome.
I'm happy to jump over to this land cover discussion just because, I'm a big NASA fan, and they do this multispectral analysis where they literally can tell, that's a crop, that's roadway, that's building, and even like toxicology things. Like you can see a bloom from effluent flow into a river, and that is growing algae or causing, damage to the ecosystem.
Yeah, yeah. So that's the idea, is just being able to take this and provide that data to anyone who needs it. And there's a big variety of ways that people might want to use it. Urban development is a huge thing. Like, where do we? What's the best way we can, construct, if we have to put real estate up, where should it go? How can we preserve the environment the best when we're doing our building, that sort of thing. There was actually a really neat conversation I had with the Office of Civic Innovation in a certain city I visited. And the city was telling me, the city government officials were telling me how they had this program where they gave away free trees to everyone.
Oh.
So anyone could sign up and get free trees. But they were trying to solve a specific problem. And the problem was that in the city limits, it was actually 10 degrees hotter than the surrounding suburbs. So they had a real problem with heat in the actual city. And a lot of that is because things like, roads have the, reflective surfaces. So it keeps that heat in the air and reflects and just makes it very hot. And trees provide natural shade and cover and kind of cool things off a bit. And so they were actually saying, oh my goodness, it would have been so much better had we used some kind of data-driven approach to figure out where to best plant those trees, rather than just kind of giving them away willy-nilly in this kind of free-for-all program. If they could have used something like this to say, okay, here's where we need more trees, and then be able to plant them in strategic locations to help bring down the heat in the city. So that was a kind of a really interesting thing I thought of. And then there's other places as well. There's a location called Tangier Island, and it's actually, the island is eroding. There's a book that's just recently been published on it. And so a colleague of mine has relatives that live on this island, and it's this kind of sad thing that they're losing their island. It's the water levels are rising, and so they're having issues with just trying to figure out how do you move forward in that kind of thing. And so using something like this to be able to track that and hopefully take some action to counteract it. And then the original use case was something that was done by the Chesapeake Conservancy. And so the watershed area in the Chesapeake Bay has they want to do precision conservation there, meaning, understanding down to the very discrete, atomic unit, where the water levels are, and then where they can best apply conservation techniques. And so having a really accurate, up-to-date land cover map would help with that. And so something that you can run in real time, just you put in aerial imagery and it will tell you things in real time. Here's where the water and land and such is. So, and
it's such a developed area, right? I mean, that's Baltimore and DC and Richmond, Virginia. There's just a lot of people that live around Chesapeake Bay. It's got to be under a lot of stress.
Yes, no, that's very true. And so that's one of the things that they're working on is being able to do conservation in a very accurate way, and be able to use up-to-date data to be able to make the best decisions for how to do that.
Has anybody been able to make a tricorder yet? Something that is a spectral analyzer, and you can point it at a leaf and it'll tell you the chemical makeup of it or something.
Yeah. So there's been some, I wish I was up to date on that, because yes, there is work happening in that area, but I don't know the latest status of it. We have a number of grantees working on a lot of different things. And I know one of them is actually they have something where they can give you, based on aerial imagery, a whole bunch of data on forests, the diameter of trees, the height of trees, all of this really great analysis of the forest land. And that's a pretty neat thing as well.
Richard probably knows. If anyone has a tricorder, it's Richard Campbell.
There's been a ton of so there was Qualcomm supported an X Prize competition for tricorders for that concept of a handheld medical diagnostic device. I believe the prize got one.
Oh, really?
And I supported a couple of Kickstarters of those things. I have a few of the gadgets, but accuracy is challenging when you're working with smartphones and untrained people trying to use these devices. Right. I mean, the best you can really count on them for doing is saying, you should probably go see a doctor.
Well, yeah. I mean, I'm thinking of the chemical makeup of stuff. Like if you point it at a off-the-shelf macaroni and cheese, for example, it'll tell you whether it's contaminated with E. coli or that kind of thing.
Yeah, that's a really interesting challenge. And, one of the things I've often thought about in the food is like how if someone tells you, hands you 2 apples, it's like one of these is organic. How do you tell?
Right.
Yeah. And this isn't this is a chemical analysis, correct?
Yeah.
Not just computer vision, right? Because, I wouldn't expect a computer to necessarily be able to do that purely on vision if it's not something that.
But the land cover mapping stuff, they use these multispectral sensors where they're sensing way up into the ultraviolet range and down into the infrared range.
Yeah,
You just see different signals.
So the API that we created works. It's a 4-band channel. It's RGB, so natural color, red, blue, as well as near infrared. So ours does use near infrared as an input as well, and that is good for things like detecting large bodies of water tend to be cooler, for example. But so do shadows. So that's one of the things that it can use that information to make smart decisions.
Yeah, up in the ultraviolet is where you pick up plant illnesses. One of the companies I worked with the Vatican on Laudato Si, they were doing precision agricultural evaluation where square by square they were able to see this group of plants is distressed because because of the way their ultraviolet light reacts, like they're a different color under UV because they're not working well.
That is so
lands
cool.
A bit drier, or the classic one was, a can of paint thinner got spilled in one square. And you didn't know it was there, but you could see in the UV that these plants were struggling from the poisoning from the paint thinner.
Wow.
That's amazing. It's so cool what's possible. It's so cool what's possible.
Well, and you're talking about this issue around effluent and runoff from farms and things. So the idea that, no farmer actually wants his fertilizer to run off into the sea. They just want their plants to be fertilized. So the idea that we could get precise enough to put only the things that are needed for that plant at that time. And drones play a role in this, but certainly machine learning to figure out plant by plant what you need to do.
Absolutely. And I think precision fertilization is a big thing, but I love the idea of precision pesticides, right? So that way we're not spraying pesticides everywhere, because it's actually, pesticides are really expensive for the farmer, and they are bad for the environment, and they're bad for us who are eating the food. So, if you can target and use things like computer vision to detect where the pests are, and then only spray pesticides where there are actually pests, where it's actually needed, like that's huge. That's cost savings.
Is that part of your Farm Beats project?
Yes, actually. Farm Beats does actually is doing work in this area now as well. Kind of their next range. But there's so much cool stuff that Farm Beats is looking at. So there's a public page that shows all of the great work that Farm Beats is doing currently. There's a lot of work in being able to increase the yield, and then being able to just use a overall data-driven approach to the farm, and understand, kind of have imagery in real time, and then be able to apply things like precision irrigation and such to the farm when you're planting. It's just so huge. It's, cost saving. It's one of those things that is just like, it's such a win-win situation all around, where it's usually cheaper for the farmer and hopefully will provide better, more yield as well.
Yeah. You make more food, costs you less to do it, and you do less environmental damage while you do it. Like it's these crazy multi-dimensional wins. So much win there. So should we jump over out of the MSR ones into some of the third-party ones? Maybe Wild Me?
I would love to. Wild Me is actually an amazing story. So Wild Me is the name of a company that created a platform called Wild Book. And so they have these wild books for various animals. So any large mammal that has distinctive patterns, so distinctive flukes or spots or stripes, anything like that, it can actually recognize an animal down to the individual animal level. So not just, zebra, not a zebra, but basically this is zebra, 2469.
Wow.
So identifying the individual animal, based on these things. And so, they have a whole bunch of different wild books. There's one for whale sharks, for example. But here's one of the things that I think is really, really cool. Like, besides the fact that they're identifying things to the individual animal, they're using really innovative use of social media to get data. And I think this is so cool. So think of all the people that go on whale watching trips and then post their pictures to like YouTube and Instagram and these sorts of things. So what they actually do is they have an intelligent agent that wakes up at 10 p.m. every night and then searches social media. And it uses like YouTube and other public things. And YouTube, for example, it can grab individual, it'll do use some NLP to be able to search for whale sharks, for example. And then after it finds YouTube videos on whale sharks, it runs computer vision to recognize, okay, is this actually a whale shark in there? And then it will apply that to a repository of known whale sharks and be able to identify, okay, this is one of the whale sharks that we know or that we don't know. And then it keeps track of all of that data over time. So this particular whale shark was noted in this location at this time, like that sort of thing. So with that data, you can actually track the migration patterns of individual animals like through the ocean. It's amazing.
Wow.
And then, yeah, and I just love the use of social media. Like, people just posting, hey, here's some cool stuff for my whale watching trip, and how that's actually helping with these biodiversity efforts and recognizing this. And they actually post a little comment in the comment section of the YouTube video that says, hey, thank you for posting this thing. We're using it for these conservation efforts, and, feel free to click on this link and you can see your individual animal. And so it takes you to this page where it links to the animal that was recognized there. And it shows, the other places that animal has been seen. So kind of a map of where it's been and its migration thing. And it also shows other known animals that it's been seen with. So it's almost like a social network for animals. So this whale shark was seen with, these other two whale sharks, and they seem to be a unit where they travel together a lot, or that sort of thing. So it's really neat for conservation efforts to be able to see how they're traveling and where they've been located. But I just love that they're using social media to be able to further that, because it's always machine learning. Data is always the hard part, right? Getting the data. And so the use of social media to procure data.
Well, what's occurring to me is that there's nothing that we can't do now, because we're so connected. We have all these tools and we have all this great machine learning, that it's really the deficit or the bottleneck is coming up with the creative ideas of how to put these things together to solve problems.
Right.
I mean, there's so many more things that we can do. We just haven't thought of them yet.
Right. Even just so another innovative use. So that's one thing. Like, I love the use of social media. The other thing is just citizen scientists. So we were talking about this earlier, right? Everyday people, not biologists, but people who are just interested in, helping the world. How can I do this in a way where I'm not a biologist, but I care about the environment and I'd love to help? There's actually an app called iNaturalist that we've worked with as well. And it's an app that you can download, iOS or Android or Windows Phone. And you can, if you're going out on a nature walk and you see some either, flora or fauna, any kind of plant or animal life that you don't know what it is, you can actually take a picture with your camera right there. And then it will actually, you can, if you know what it is, you could just enter in the species. But if you don't, there's this show suggestions, and you can click on that button, and it's using a computer vision classifier to be able to say, okay, here's the top 10 things that we think it might be. And it can also use location. If you have the location turned on your phone, it can say that, this particular duck, for example, is found in North America, but not found in Europe. So it can use data from the location as well as computer vision of things that look similar to be able to hone in on what species it is.
Yeah.
And so then it turns into just a matching game that, kids that are like 12 years old could do, where you look at the animal, the picture that you just took, and here's a couple different species, and see, okay, it looks most similar to this one. So you click on that, and then you've labeled your data essentially. So this allows people to help with labeling their data, and then that's sent off to a group where biologists and conservationists can just use this labeled data set for doing their work. So it's a great way to enable citizen scientists. Anyone just taking a nature walk can take pictures of plants or animals and then be able to provide that data. It's cool because you get to actually learn something. I mean, we've used it in one of my colleagues was using it in the backyard. He saw a snake and was like, oh my gosh, what kind of snake is this? And was using the iNaturalist app just to get the suggestions to pop up and recognize, oh, okay, it's this one.
Awesome.
So it's fun for you as a user to, learn what something is. And then it's great information because that labeled data set is now available for anyone to use.
Oh, that's so cool.
Well, I've just installed iNaturalist on my phone because this is such a good idea.
Yep.
Isn't that
it's
cool?
exactly that. It's like, what is this mushroom, or what is this tree? And so it's giving you information, and you're also contributing to this pool of this plant or this animal has been seen in this location.
Exactly. You're both giving back this data, and it's useful because I'm one of those people who did not put in my own landscaping. You guys, I'm so horrible. Like my house is just like whatever the last person, the flowers that they put in are just the flowers that are remaining there. And so my husband and I actually wanted to trim back some of this big huge flowering bush was overtaking our yard, and we were trying to learn what's the best way to do this, but we wanted to make sure, what kind of plant is this actually? We think it might be this, but and so the app is just great for things like that, just for identifying it as well.
Absolutely. No, that's very cool, and what a neat way to gather some data and hopefully do some good as well. And in the meantime, just exercise these models. I got to presume everything we're talking about here is just running on Azure. Like that's where this stuff lives.
Yes. So a lot of the grant money is done as Azure credits. So people have credits to be able to use Azure Cloud Compute or storage or whatever they need in the cloud to be able to make these things effective. And some of them are, Azure is powering most of these. Probably all of these, I think, all of these grantee work, as well as all of the work that we're doing in Microsoft Research and stuff. So Azure's basically the engine that kind of runs underneath everything.
Nice.
To make all these things possible. Yeah.
That's very cool. So what kinds of, do you get to see the applications themselves or what people want to use these things for?
Yes, I think a lot of times. So I fortunately am not the person that has to go through all of the grant applications and decide because my colleague Bonnie does that, and I do not envy her that task of like reading through all the applications and deciding. But a lot of times that is like one of the things is how do people want to use this, and is it something that is gonna have impact? And so that is definitely one of the things that we look at. But I most definitely am trying to play with as many of them as I can. Yeah. Some of them are harder to use than others. I mean, iNaturalist is great because I can use that with my kids on a nature walk, and it's open to everyone. And things like the wild books are also you can go to whaleshark.org and be able to check out various locations of animals and see all of that yourself too. But some of it is a little bit more restricted. So if you think about things like poaching, so there's a lot of work being done to be able to detect poachers and where are they using, drones to be able to monitor some of these areas where there's known poachers.
Well, that sort of turns into a law enforcement app, doesn't it?
Exactly. But that's something where we could really use help, like both computer vision to recognize that, okay, there's these unauthorized people moving through this area, as well as locating, where the animals are and things like that. So there's a lot of computer vision there, but then you can also use machine learning for things like being able to predict, where the poacher is going to go next, or if I catch up with them, which way are they going to run, or what's their most likely target tonight. Like if I have a limited number of rangers, which there are, it's always a limited resource, the people that you have available, like where's the best place to send them where we think poaching is most likely in this evening. So there's a lot of work being done out of the University of Southern California in this area. And so we've been supporting them and partnering with them on a lot of their great work in the area of poaching. But that's very sensitive data that, we don't want to necessarily, a lot of this data is locations of these animals that are subject to poaching. And
Right.
that's something where you have to be very careful who gets access, because you don't want that to fall into the wrong hands.
So is there a place where we can go and look and see what projects are underway, at least which ones are publicly visible?
Absolutely. So we have a series of featured projects on our AI for Earth website. So do check out the AI for Earth website. That is probably the best place to learn about all of the work that we're doing. And then you can also follow on Twitter, myself, Jennifer Marsman, as well as the Microsoft Green account. And that's Microsoft_Green. And that's our environmental sustainability alias. And so a lot of these environmental applications are published on that Twitter account and on that blog as well. There's also a Microsoft Green blog and my own blog as well. So those are all great resources to keep up to date on the amazing work that's being done with machine learning around sustainability.
You must be so happy in this job. I mean, I can't imagine. You get to play with data and save the world at the same time.
It's so cool to be able to use machine learning to do something like so exciting. It definitely does get me excited about coming to work every day.
So awesome. Jennifer, thanks for spending this hour with us. It's been great.
Most definitely. Thank you for having me.
You bet. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a toy boy. Life is hard.